except I have to do a normalization to remove the choice set that has no alternatives. Okay, so we just account for that zero-member choice set. Okay, but that's the probability of a choice set for individual Q. And in the second stage, we have the multiple discrete continuous extreme value model. This is simply representing the probability of individual Q making one or more choices given the choice set C. Right? So you have a choice set C, right? So now it's the probability, choice of one or more alternatives, PQ given C, probability of making a choice or one or more choices given that choice set. That's given by this formulation. It's right out of the basic MDCEV model formulation, right, for the probability form. Okay? So I won't necessarily go into details except to say that as part of that, we do model the mileage. Okay? So the EI star is the mileage corresponding to an alternative. There are some parameters that we introduce, gamma and alpha, and those parameters are satiation parameters. Okay? And the satiation parameters are basically accounting for the fact that too much of anything is probably not good for you. So, you know, even if you're eating a lot of cake, after a while, enough is enough. So, these satiation parameters just account for the fact that after a while, you're ready to move on. Right? So you want to terminate the activity, and you want to just go and do something else. So that's what those satiation. You are satisfied and ready to go. And then, you know, we estimate a vector of coefficients. So this model formulation takes into account several behavioral aspects. This is the bottom line. Okay? You have a probability for an individual Q is simply the product, right, of that individual Q choosing one or more alternatives from a choice set given the feasible choice set C times the probability of that choice set emerging for the individual. Right? A very basic formulation. Prior to this slide, I simply showed you the form of this probability function and the form of that probability function. That's all I did. Okay. So a very nice, straightforward application of a latent choice set generation model with a multiple discrete continuous extreme value model. We use the NHTS data that I think many might be aware of, the 2009 National Household Travel Survey data. Of course, it has 150,000 plus households, 320,000 plus persons. We don't want to deal with such large samples for our model estimation efforts, so we really can control the sample that we're dealing with. In some of our previous work, we've put together extensive land use data for the San Francisco Bay Area. So we extracted the San Francisco Bay Area sample so we could integrate some land use measures and built environment measures into the sample data set. We looked at employed individuals because this is non-work activity scheduling for workers. So we're looking at workers aged 18 plus years who reported travel on weekdays. So we had a final estimation sample of about 1,000 plus persons, much nicer for a model estimation of this nature. And non-work activities were coded into these 5 time of day periods. Mileage also was calculated for 3 modes, auto, transit, and non-motorized. So you really had a total of 15 alternatives, 5 times 3, the 5 time of day periods times the 3 modes of transportation. Okay. Here's some sample characteristics. Nothing too unusual for a exclusive worker sample, right? So it's not representative of the general population. You know, slightly higher on the females. Interestingly, we had quite a high percent that reported no non-work activities. So 31% just went to work, worked hard, and went back home. So they just didn't do non-work activities. Individuals more than 50 years, so slightly older sample, again because it's kind of a worker, exclusive worker sample. 67% in households with 2 adults, 56% actually had no children, again maybe representing the slightly older age nature of the sample. A very high income group But again, this is San Francisco Bay Area, so maybe you can moderate that income number a bit. So this is non-work activity engagement. I think all I wanted to really point out here is how you see larger percentages of people performing their non-work activities kind of in the after-work time periods. So you'll see smaller percentages pursue non-work activities in the early part of the day, but after work, everybody's trying, a lot of people are trying to do other stuff as well. So you'll kind of see these higher percentage of non-work activity engagement after work, and then you see the non-auto tour as well. We just calculated that separately. So the latent choice set MDCEV model, so we took two model forms, the latent choice MDCEV model that takes into account the choice set formation, and we did the pure MDCEV. That is, I assume 5 time periods are in everybody's choice set. Okay, the pure MDCEV, ignoring the choice set formation model. All right, and there are some key differences that we found between these two, clearly suggesting that the latent choice set generation model really added a lot of value in modeling this choice process. Okay, so variables significant in the latent choice came out insignificant in the pure MDCEV model. Coefficient parameters in the pure MDCEV model were inflated in comparison to the coefficients in the latent choice set MDCEV model. So it looks like the coefficients you're getting from the pure MDCEV is kind of a mixture of the effects, right? These coefficients are accounting for the choice set generation process as well as the actual choice process. And you're not able to separate those two effects, okay? So your socio-demographic characteristics affect both of these phenomena. Affect both whether an alternative is in your choice set and affects whether you are going to actually choose it, right? And if you do the pure MDCEV, you're not being able to separate those two effects, okay? So again, this latent choice set MDCEV offered a lot for us to be able to more accurately reflect these behavioral processes. So these were some of the variables that impacted these choice processes. So very behaviorally intuitive results. I'm not going to present these massive tables with coefficients and p-statistics. They're just a blur. So, but essentially, just trust me. The models were good, and the p-statistics were all wonderful. So we were very happy with the way the models came. Okay. Oh, I actually do give you at least goodness of fit statistics, and that wonderful asterisk there means it is better than the others. So if you look at the latent MDCEV, big difference in the likelihood at convergence, big difference in the adjusted likelihood ratio index, and again a big difference in the Bayesian information criterion. Smaller the better with the BIC. Okay. So again, just big difference. All right. Decision paradigms. So let's see. How much time do I have?
Maybe 5 more minutes and then questions?
Okay.
Okay?
That is just wonderful. I am very adaptable.
Okay.
So this was the second one. And here I'm just going to present the idea. That way I can skip over most of the slides. They just shoot you bullet by bullet. So basically the idea is, if you think about households make some long-term location choice decisions. Residential location, where to live, and workers in the household have to think about where to work, right? Job location choice. And of course, it's not like you can choose any job location, you've got to get the job. But you can target your job location search, perhaps based on your residential location, or vice versa. You can target your residential location search based on where you found work, right? And if you think about this bi-directional process, right, there's probably some households or some workers who chose a residential location based on their work location, and there's probably other households and workers who chose their, I don't know which one I just said, but who chose their residential location based on their work location. If you actually look at the literature, it's dominated by the assumption that residential location choice is affected by work location choice. Okay, that people try to, have a work location and then try to perhaps optimize or kind of look at their commuting times and find a residential location choice given the work location choice. But does that really apply to everybody? The population is likely to be very heterogeneous. You're very likely to have people who are in fact finding a work location choice based on where they live. So it's convenient. And so we wanted to be able to come up with a model system that relates residential and workplace location choices while accommodating both causal structures. But I have no idea who is adopting one causal structure versus the other. So I've got to use a latent construct, right? This is the unobserved decision structure that's existing in the population. I need to use a latent construct in order to segment my population. Here's the group of households who did residential location choice affecting work location choice, and here's the group of households for whom work location choice affected residential location choice. Okay? So that's basically what this work was about, was trying to come up with the latent decision structure that prevails in the population. Okay? So two major long-term location choices, household and work location choice. You can have which one comes first. Okay? And I do recognize it is a cyclical relationship perhaps, but you can still think about situations, or basically these two directional situations, one affecting the other or the opposite, and you have both prevalent in the population. I just need to know how to segment the population and identify households that belong to each causal structure. Okay? That's what we're after. Okay? So in a behaviorally heterogeneous population, both mechanisms likely to exist. Okay? This is right out of the paper that we had with Professor Paul Waddell, again Chandra Bhatt, myself. This was again in our trying to do some integrated land use transport modeling. We did this paper on interdependent household location and work location choices. This is a quote that essentially ends with the words, if you don't account for this heterogeneity, you are distorting the policy evaluation of transportation investments or land use regulations. Okay, a pretty powerful statement. So hopefully I've convinced you that what we did was valuable. So here's residential work location choices. We don't know who is who. Another big problem with this residential work location choice problem, if you have 1,000 locations, and I had to exhaustively enumerate all possible combinations, that's 1,000,000 choices, right? 1,000 residence work location combinations times 1,000, so it's 1,000,000. So this becomes an exploding choice set problem as well. Okay, so that just talks about the exploding choice set problem. I've convinced you of that. The model formulation here is rather extensive, okay, so I will skip over this. But this is, again, we're just looking at these two segments. Probability of choosing a work location given a residence location, okay? And you can kind of, you can integrate that function in order to get the unconditional probability, okay? So not an issue there, so just to construct the likelihood function, okay, for model estimation. Here's the other way around. Probability of residence location given workplace, okay? So this is the other population segment. You can, again, integrate that out as well, right? Then you actually need the probability of you're falling into one of the other segments, okay? Which causal structure do you adopt, okay? So that is this. If you fall into the probability of residence first, so the probability you're in the other segment is 1 minus of that, okay? And you can then just multiply this out to get the probability for the entire choice process. So the probability that you are choosing a residence location, workplace location combination. IK is a residence workplace combination, okay? Is given simply by this formulation. Pretty straightforward probability formulation that you can just write out. That gives you a likelihood function that you can maximize, estimate parameters, and be very happy. So it's quite straightforward. I wanted to end this with, so we have different equations and model specifications. We use different types of variables. We had 900 traffic analysis zone situations. So if you had to do the classic model, it would be 900 times 900, which is quite formidable, even with simple multinomial logic. But then you have all kinds of other problems with the multinomial logic. Okay, so we used a data set that's a little dated now, but at the time it was reasonably good, and it had lots of land use variables appended to it. So that's why it was perfect for location choice modeling. And the final sample had about 1823 households. We tried to simplify the problem by considering one-worker households, because once you start having multiple worker households, that's a whole nother level of complexity, with multiple workers optimizing residence work location choice decisions. So we went with the one-worker households. We estimated different types of models. The joint model, right, where you had both of these latent segments prevalent in the population, provided superior goodness of fit, and so indicating we had benefit. What I wanted to leave you with is the fact that the findings were quite counter to what we started off with. We had assumed that a vast majority would have the work location is given and residence location is based on work location. Completely the opposite. We have 81% of the households falling into the category where the residential location is given and drives the work location choice. We're still struggling with this one, I will say. But it was just fascinating enough, I just had to share it with you. So it's here. And you know, I mean, it is interesting. And indeed, in some of our panel data, we do find people changing jobs more often than they change home locations. And so perhaps this is really reflecting that job mobility, whereas you have a fixed home location. So, then we did have some other interesting findings as well, that there's more dispersion in the residential choice-making process as opposed to the workplace work location choice-making process, which is also kind of interesting as well. There may be more degrees of freedom with residential choice than with work location choice. Okay, here we had some elasticity computations showing what was your sensitivity to falling into one group or the other in terms of that behavioral structure, you know, in response to socio-demographic characteristics. So we found that actually, you know, depending on your life cycle, income, and so on, that affected which behavioral decision structure you tended to adopt. So implications and conclusions. Just wanted to note again, we believe these latent constructs offer a lot in terms of being able to model activity travel choice behavior and in being able to come up with more accurate forecasts, land use forecasts, right, as well as travel forecasts, say even in the mode choice context when you're doing light rail investment studies or any mode choice type of studies. We find substantial difference between models that ignored versus those that used latent constructs. So, you know, we're trying to further document some of the policy implications of these models and think about the implications for data collection efforts. So we're actually trying to convince some of the MPOs and so on, including Southern California, where we're doing their activity-based travel model, that in their next household travel survey, they should include questions that try to get at some of these latent things, or you know, include questions about awareness, consideration, which choice affected the other, right? Trying to get that kind of information. So with that, I thank you very much.
5, but maybe let's take 5 minutes for questions, just so we have an opportunity.
This second paper, the one that I'm presenting on, I read that paper quite closely and was very interested in it. And we thought that we were going to get access to the RDC, is it the Census Remote Data Center, that would answer some really great questions that could continue that work. That is not happening. But I was wondering, what if you had your choice? Like, what would be your next step with that research?
You know, that is a good, I think really we would want to just be able to collect more in-depth data from individuals directly and be able to find out perhaps, which decision might have affected the other. But more importantly, I think if we can start using more longitudinal data or panel data, that kind of gives us a sense of how people are changing their location choices, and you can kind of relate that to changes in their either the built environment or changes in household structure and composition over time, or their work situations over time. I think that can give us a lot. So, if you think about residential and workplace location choice connection, the time dimension is a natural component of it, because all location choices have a lag, right? If you're responding to a change in job, it will take you some time to make a residential